Now in this article we find the condition for parallelism of two lines. That is, here we have to find the condition if two lines are parallel in the space. So first we write here Lagrange's identity. So Lagrange's identity is L1 square plus M1 square plus N1 square multiplied by L2 square plus M2 square plus N2 square minus L1 L2 plus M1 M2 plus N1 N2 whole square. This is equal to M1 M2 N1 N2 determine square of the determinant of M1 M2 N1 N2 plus square of the determinant of L1 N2 L1 L2 plus square of the determinant of L1 L2 and M1 M2. And this determinant, value of this determinant can be written as M1 N2 minus M2 N1, because here we draw cross multiplication. So here N1 multiplied by L2 minus N2 multiplied by L1. Similarly here L1 multiplied by M2 and L2 multiplied by M1 whole square. So this is the Lagrange's identity. Now we know that sine square theta, this is equal to 1 minus cos square theta, and we know that since cos theta equal to L1 L2 plus M1 M2 plus N1 N2, where L1 M1 N1 be the direction cosines of one line and L2 M2 N2 be the direction cosines of the second line. So sin square theta is equal to 1 minus cos square theta. Now we put value of cos theta. So this can be written as 1 minus L1 L2 plus M1 M2 plus N1 N2 whole square. So in place of 1 we can write here, L1 square plus M1 square plus N1 square multiplied by L2 square plus M2 square plus N2 square minus L1 L2 plus M1 M2 plus N1 N2 whole square. So we know that if L1 M1 N1 are the direction cosines of one line, then sum of the squares of L, M and N is equal to 1. So we know that L1 square plus M1 square plus N1 square is equal to 1, and L2 square plus M2 square plus N2 square is also equal to 1. So 1 multiplied by 1 gives 1. So sin square theta can be written as this one. Now we can write this sin square theta. This can be written as, from the Lagrange's identity, we can write here M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square plus L1 M2 minus L2 M1 whole square. Now we taking square root of this and get value of sin theta. So sin theta is equal to plus minus under root M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square plus L1 M2 minus L2 M1 whole square. So this is the value of sin theta in terms of the direction cosines of two lines. Now we know that if A, B, C, A1, B1, C1 and A2, B2, C2 be the direction ratios of two lines, then L1 is equal to A1 upon under root A1 square plus B1 square plus C1 square. M1 is equal to B1 upon under root A1 square plus B1 square plus C1 square, and N1 is equal to C1 upon under root A1 square plus B1 square plus C1 square. Since we know that this is the relation between the direction cosines and direction ratios. If direction ratios are given, then the direction cosines can be written from these formula. Similarly, L2 is equal to A2 divided by under root A2 square plus B2 square plus C2 square. M2 is equal to B2 divided by under root A2 square plus B2 square plus C2 square, and N2 is equal to C2 divided by under root A2 square plus B2 square plus C2 square. Now we put value of L1, M1, N1 and L2, M2, N2 in the above formula. So sin theta can be also written as, here we put value of M1 and N2. So M1 is B1 upon under root A1 square plus B1 square plus C1 square, and N2 is C2 upon under root A2 square plus B2 square plus C2 square. So we put value of M1 and N1 and similarly M2 and N1 in this bracket. So we can write this under root, we can write this B1 C2 minus B2 C1 whole square plus C1 A2 minus A2 C1 whole square. Here we write N1. N1 is here C1 and L2 is here A2. C1 A2 minus this is C2. So this can be written as C2 A1 whole square plus, here we write L1 M2, that is A1 B2 minus A2 B1 whole square, divide by under root A1 square plus B1 square plus C1 square under root A2 square plus B2 square plus C2 square. So when we put here value of L1 M1 N1 and L2 M2 N2, we get the value of sin theta in terms of the direction ratios of two lines. Now if two lines are parallel, then angle between them is 0, so we can write sin theta is also 0. If two lines are parallel, so the angle between them theta is equal to 0. If we find sin theta, so sin 0, that is equal to 0. Now we put here in this formula sin theta, we put value of sin theta in above formula, we get 0 is equal to plus minus under root M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square plus L1 M2 minus L2 M1 whole square. Since this is the square, this is this bracket are positive quantities because here is square. So if all these three terms are 0, so value of this term will be 0. So m1 n2 minus m2 n1 is equal to 0. N1 L2 minus N2 L1 equal to 0. L1 M2 minus L2 M1 is equal to 0. Value of this term will be 0 when each term are equal to 0, because these are the positive quantities. This is the sum of the positive quantities. Now this can be written as m1 upon m2 is equal to n1 upon n2. From here we can write n1 upon n2 is equal to l1 upon n2, and from here we can write l1 upon l2 is equal to m1 upon m2. So from the above we can write l1 upon l2 is equal to m1 upon m2 is equal to n1 upon n2. So by the property of ratio and proportion, we can write here L1 square plus M1 square plus N1 square divided by under root L2 square plus M2 square plus N2 square. This is the property of the ratio and proportion. Now we know that L1, M1, N1 and L2, M2, M2 are the direction cosines. So if sum of the squares of this is 1, here this can be written is equal to 1 and this is also 1. So from here if we solve L1 upon L2 is equal to 1 by 1, we get L1 is equal to L2. If we solve M1 upon M2 is equal to 1, so we get M1 is equal to M2. If we solve N1 upon N2 is equal to 1, so we get N1 is equal to N2. That means if two lines are parallel, so their direction cosines are equal. So if two lines are parallel, then their direction cosines are also parallel. Then their direction cosines are equal. So this is the condition for parallelism of two straight lines. If two straight lines are parallel, then their direction cosines are equal. That means if the direction cosines of two lines are equal, so lines are parallel. Now from the second formula, if we put sin theta equal to 0 in this formula, so we get b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square is equal to 0. Suppose this is second formula and this is one formula. So if we put sin theta is equal to 0 in second formula, second equation, so this is the sum of the positive quantities, so each term will be equal to 0. Value of this term is 0 when each of the term is equal to 0. So we can write here b1 c2 minus b2 c1 equal to 0, c1 a2 minus c2 a1 is equal to 0, and a1 b2 minus a2 b1 is equal to 0. From these conditions, these three conditions, we can write a1 upon a2 is equal to b1 upon b2 equal to c1 upon c2. This is the condition for parallelism of two straight lines in space. That is, if the ratio of the direction ratios of two lines are equal, so the lines are parallel. Thank you.